Welcome. So we finished our study of angles, and now we're going to look at the concept of arc length in a little bit more detail, and then look at arc length specifically on the unit circle, define what that is, and then in this video define the trigonometric functions using arc length. So again, we're working with the unit circle, and when I talk about the unit circle, it is a circle, but it is a circle where it is a circle of radius 1 centered at the origin. And if you're interested in the algebraic representation, we will be eventually interested in it. There it is, x squared plus y squared is equal to 1. So again, if you can imagine a radius 1 circle, and I am going to do my best free-handed sketch. If I wanted to get a more precise drawing, I would use a tool. Okay, but that's a circle. I'm the world's best artist, so I say that's a circle. It's a circle. But in any case, again, at any point on the circle, if I look at the radius, which would be from the origin out to a point on the circle, that radius is going to be 1. And I can talk about the unit circle intersecting the points 1, 0, 0, 1, negative 1, 0, and 0, minus 1. And again, if your drawing isn't a perfect circle like mine, it's okay. Just make sure to label the points on the circle. Okay, so there we are. We have the unit circle. We're going to be doing a lot of work with this. And again, if you're more interested in the general form, I'm not going to spend time on it, but there it is. H and K represent the center, R is the radius. Okay, so now our work today, we're going to look at the arc length along the circumference, aka edge, of the circle, from the point 1, 0, so that's this point here, to a generic point P of xy. And let's put xy over here, just for fun. Okay, so we're going to look at if this, I want that a different color. Let's do green. Let's do it along the edge here. So we're looking at that arc length. I'm going to call it T, and I know we maybe use a different symbol for it, but it's fine. But we can write the equation that relates T and the radius is T is equal to R times theta. Okay, and again, here, if we're looking at any generic point or any generic radius, it's 1. Okay. Also, one quick comment, if we're looking at T and we assume T is positive, then that's going in a counterclockwise fashion. If we're looking at negative T, or if our arc length ends up being negative, again, that would just be the same arc length measured in a clockwise fashion. Okay, just a point to remember. All right, so now what we can do is we can start to form different ratios. Okay, we can start relating T, R, and theta in different ways. And theta is actually a little bit tricky. So what we're actually going to end up using is the point, or the coordinates of the point. Okay, the point pxy. Okay, and with those we form 6 trigonometric functions from those ratios. Okay, so you can read the full definition, but T is the arc length from 1, 0 to the point P of xy, and we get these 6 trig functions. Now, the main ones that we're going to deal with are highlighted in yellow. Okay, I have them arranged in this way for a particular reason. Before I get there, though, okay, if we look at the function name, or the function sine, okay, it's abbreviated as sin, okay, but we always say sine, okay, sine, and then this is the function, so this is the input, so domain element, and then what we get out over here, that's our range element, or our output, okay. Notice that the output is indeed a ratio, okay? It's a ratio of the y coordinate of the point, right, to this 1, which is the radius on the unit circle, okay? Then if we look at cosecant, so we're going to call that a cofunction eventually, but cosecant is the reciprocal, okay? 1 over y. Again, we're putting in arc length into the function and getting out this ratio. Okay, next big one is cosine. Again, cosine, we input the arc length and we get out a ratio that is the ratio of the x coordinate to the radius. okay? Tangent is the ratio of the y-coordinate to the x-coordinate if we input the arc length, okay? Note that in this case, since we have a variable denominator, we cannot have the denominator being 0, okay? Now, in working with trig functions, I have to offer a few cautions, okay? The first one being, please, please, please be careful with notation. Okay, when we use the notation sine of t, and I really hate textbooks for this, but sometimes they omit the parentheses. You should always imagine the parentheses in there. It's not like it's saying multiplication there, okay? T is the input into a trig function. A trig function needs an input element, okay? So just be careful with that. Textbooks will sometimes indicate this, but multiplication is not okay. All right. And then also in this, we've been assuming that t, our arc length, is positive. Well, again, if it's negative, it just kind of goes the other direction around the unit circle. But the ratios remain unchanged in the sense that you still do the y coordinate over, or the y coordinate over 1 for the ratio for sine. Okay. So just a quick example with all this. Okay. So we have t extending around the unit circle counterclockwise, so it's going to be positive from the point 1, 0. So I'm just going to draw a quick sketch because I need a picture. So it's going to go from 1, 0 to the point negative 3/5, 4/5. So negative 3/5, 4/5, maybe about there. And I'm going to label that just for clarification. Okay, so t is this little bit around the unit circle, going like that, in that manner. So it says draw t. Oh, well, I did that. Yay, yay me. And then find the value of tangent of t. Okay, so tangent of t. Okay, from the table above, I see it's the ratio of the y-coordinate to the x-coordinate. And when I do that, the y-coordinate of the point is 4/5. Actually, let me write that differently. I'll do 4 over 5. And then the x-coordinate is negative 3 over 5. Okay, and if I simplify that, okay, again, I would multiply by the reciprocal if I'm dividing a fraction by a fraction, times by negative 5 over 3. 5s would reduce, and I'm left with negative 4 over 3. So there we go. So with each of the trig functions, it's important to pay attention to the ratio and how they're defined. It's also important to keep track of a notation, okay? I see a lot of students, okay, I'm just going to offer one last warning before we end. A lot of students write tan is equal to negative 4 over 3, okay? That is not okay, okay? The reason I say that is if you write sine without an angle, okay, it'd be 4/5 in this case, okay? Sine without an angle is a sin. You'll hear me say that over and over and over in class, but we need something to go in there because our output is well defined, but we don't know what goes in it. So remember your inputs on your trig functions, okay? We'll get some more practice with this coming up.